National Electrical Code mandates specific requirements for electrical installations in underhouse spaces, particularly concerning receptacle outlets and lighting. Addressing the placement of receptacle outlets, the NEC stipulates that a receptacle outlet must be installed within 6 feet of any point within the underhouse area. This requirement ensures convenient access to electrical power for various purposes, such as powering tools or equipment used for maintenance or repairs under the house. The intent is to minimize the use of extension cords, which can pose safety hazards and are often not rated for outdoor or damp locations. Regarding lighting, the NEC requires the installation of a light fixture if the underhouse space is accessible by any means. This accessibility could be through a door, hatch, or other opening that allows entry into the space. The purpose of this requirement is to provide adequate illumination for safe navigation and work within the underhouse area. Insufficient lighting can create hazards such as tripping, falling, or difficulty in identifying potential problems with the structure or utilities. Furthermore, the NEC mandates that the light fixture installed in the accessible underhouse space must be controlled by a switch. This switch must be located outside of the underhouse space and within 6 feet of the access point. The location of the switch ensures that individuals can easily turn on the light before entering the space, preventing them from having to fumble in the dark to locate a switch inside. It also allows them to turn off the light upon exiting, conserving energy and preventing the light from being left on unnecessarily. For complete and detailed information regarding these requirements, refer to NEC Section 410.8. This section provides comprehensive guidelines for lighting fixtures, lamp holders, lamps, receptacles, and other equipment, covering various aspects such as installation, support, wiring methods, and specific requirements for different locations, including damp or wet locations like underhouse spaces. NEC Section 410.8 outlines the requirements for luminaires in damp or wet locations. It specifies that luminaires installed in damp locations must be identified for use in such environments. Damp locations are defined as areas that are subject to moderate degrees of moisture, such as some basements, some barns, some cold storage warehouses, and under canopies, marquees, roofed open porches, and similar locations. For luminaires installed in wet locations, the NEC requires that they be identified for use in wet locations. Wet locations are defined as areas subject to saturation with water or other liquids, such as unprotected locations exposed to weather. The underhouse space could be considered a damp or wet location depending on site-specific conditions such as drainage. The NEC also addresses the type of wiring method suitable for use in underhouse spaces. It typically requires the use of wiring methods that are approved for damp or wet locations depending on the specific conditions of the underhouse space. Common wiring methods used in these areas include non-metallic sheath cable, electrical metallic tubing, and rigid non-metallic conduit. When installing receptacles in underhouse spaces, the NEC requires that they be of the grounding type and be protected by a ground fault circuit interrupter, or GFCI. GFCI protection is intended to protect people from electrical shock hazards. GFCI protection is required for all 125-volt single-phase, 15 ampere and 20 ampere receptacles installed in damp or wet locations. The NEC contains provisions regarding the minimum height of electrical equipment installed in underhouse spaces. These provisions are intended to protect the equipment from physical damage and prevent it from being submerged in water. In areas subject to flooding, the NEC requires that electrical equipment be located above the base flood elevation. The NEC mandates that all electrical work be performed in a neat and workmanlike manner. This includes properly supporting and securing cables, making connections in approved enclosures, and ensuring that all equipment is installed according to the manufacturer's instructions. The NEC requires that all electrical installations be inspected and approved by a qualified electrical inspector. The inspector will verify that the installation complies with the requirements of the NEC and other applicable codes and standards. The inspector will also ensure that the installation is safe and free from hazards. NEC Section 314.27 covers outlet boxes. This section addresses the requirements for outlet boxes used for lighting fixtures, receptacles, and other electrical devices. It specifies the types of boxes that are permitted, the methods of support, and the requirements for box fill. NEC Section 314.27 covers boxes at luminaire or lamp folder outlets. It specifies that outlet boxes used as the sole support for a luminaire or lamp folder must be listed and marked for the maximum weight of the luminaire or lamp folder they are designed to support. The box must also be securely attached to the building structure. NEC Section 314.27b covers outlet boxes used for receptacles. It specifies that outlet boxes used for receptacles must be of sufficient size to accommodate the receptacle and all of the wiring connections. The box must also be securely attached to the building structure. NEC Section 314.27c covers outlet boxes used for other devices. It specifies that outlet boxes used for other devices, such as switches and dimmers, must be of sufficient size to accommodate the device and all of the wiring connections. The box must also be securely attached to the building structure. NEC Section 314.27d covers box fill. It specifies the maximum number of conductors that are permitted in an outlet box. The box fill is determined by the size of the box and the size of the conductors. The NEC specifies the types of wiring methods that are permitted for use in under-house spaces. The wiring methods must be suitable for the environment and must be installed in accordance with the NEC. The wiring methods commonly used in under-house spaces include non-metallic sheet cable, electrical metallic tubing, and rigid non-metallic conduit. The NEC requires that all wiring in under-house spaces be properly supported and secured. This prevents the wiring from becoming damaged or creating a hazard. The wiring must be supported at intervals not exceeding 1/2 feet and within 12 inches of every box, cabinet, or fitting. The NEC requires that all electrical connections in under-house spaces be made in approved enclosures. This protects the connections from moisture and physical damage. The enclosures must be suitable for the environment and must be installed in accordance with the NEC. The NEC requires that all electrical equipment in under-house spaces be properly grounded. This protects people from electrical shock hazards. The grounding system must be installed in accordance with the NEC. The NEC specifies the types of overcurrent protection that are required for electrical circuits in under-house spaces. Overcurrent protection devices, such as circuit breakers and fuses, protect the wiring and equipment from damage due to overloads and short circuits. The overcurrent protection devices must be sized appropriately for the circuits they protect. The NEC requires that all electrical work in under-house spaces be performed by a qualified electrician. A qualified electrician has the knowledge and experience to install electrical wiring and equipment safely and in accordance with the NEC. The NEC requires that all electrical installations in under-house spaces be inspected and approved by a qualified electrical inspector. The electrical inspector will verify that the installation complies with the requirements of the NEC and other applicable codes and standards. The electrical inspector will also ensure that the installation is safe and free from hazards. The NEC Section 314.16 covers the number of conductors allowed in outlet boxes. The general requirements for box fill are found here. The number of conductors permitted in a box depends on the volume of the box and the size of the conductors. Table 314.16 provides the dimensions for standard metal boxes, while Table 314.16b provides the dimensions for standard non-metallic boxes. The volume of other boxes must be marked on the box. Each conductor that originates outside the box and terminates inside the box, each conductor that splices within the box, and each conductor that continues through the box counts as one conductor. Each loop of wire that is unbroken and continues through the box counts as one conductor. Equipment grounding conductors are permitted to be installed in the box, and up to a certain number of these do not count toward box fill. For example, if the box contains 4 or fewer equipment grounding conductors, these do not count toward the box fill. If the box contains more than 4 equipment grounding conductors, the number of equipment grounding conductors that count toward the box fill is 1. Conductors are counted based on their size. Conductors of size 14 American wire gauge count as 2 cubic inches. Conductors of size 12 American wire gauge count as 2.25 cubic inches. Conductors of size 10 American wire gauge count as 2.5 cubic inches. Conductors of size 8 American wire gauge count as 3 cubic inches. And conductors of size 6 American wire gauge count as 5 cubic inches. Cable clamps also count toward box fill. One or more internal cable clamps count as one conductor, based on the largest conductor entering the box. Likewise, fixture studs or hickes also count toward box fill. One or more fixture studs or hickes count as one conductor, based on the largest conductor entering the box. The NEC requires that all electrical work be performed in a neat and workmanlike manner. This means that the wiring must be properly supported and secured. The connections must be made in approved enclosures, and the equipment must be installed according to the manufacturer's instructions. The NEC Section 110.12 covers the requirements for neat and workmanlike manner. It specifies that all electrical work must be performed in a neat and workmanlike manner. This includes properly supporting and securing cables, making connections in approved enclosures, and ensuring that all equipment is installed according to the manufacturer's instructions. The NEC requires that all electrical equipment be installed in accordance with the manufacturer's instructions. This ensures that the equipment is installed safely and will operate properly. The NEC also requires that all electrical equipment be properly maintained. This includes keeping the equipment clean and free of debris and making sure that all connections are tight. Regular maintenance will help to ensure that the equipment operates safely and reliably. The NEC contains many requirements for electrical safety. These requirements are intended to protect people from electrical shock hazards and to prevent electrical fires. It is important to follow the requirements of the NEC when performing any electrical work. The NEC is a complex document, and it can be difficult to understand all of the requirements. If someone has any questions about the NEC, it is important to consult with a qualified electrician. A qualified electrician will be able to answer any questions and help to ensure that the electrical work is performed safely and in accordance with the NEC. The NEC is updated every 3 years. The most recent edition of the NEC is the 2023 edition. It is important to use the most recent edition of the NEC when performing any electrical work. The NEC is available for purchase from the National Fire Protection Association or NFPA. The NEC is also available online. The NEC Section 210.8 covers ground fault circuit interrupter protection for personnel. This section requires GFCI protection for all 125-volt single-phase 15 ampere and 20 ampere receptacles installed in dwelling units in certain locations, including bathrooms, garages, and outdoors. GFCI protection is also required for all 125-volt single-phase 15 ampere and 20 ampere receptacles installed in other locations where there is a risk of electric shock, such as near water. A GFCI is a device that protects people from electric shock by detecting ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person's body. A GFCI will trip and shut off the power when it detects a ground fault, preventing electric shock. GFCI protection is required in many locations to help protect people from electric shock hazards. GFCI protection is especially important in areas where there is a risk of water exposure, such as bathrooms and outdoors. It's important to remember that the NEC is a comprehensive set of standards. Consulting the latest edition and seeking guidance from a qualified electrician are crucial steps to ensure safe and compliant electrical work.